So now that you have a high-level view of what the Completable Future framework is intended to do, we talked about at a high level how it addresses some of the limitations with classic Java futures. Let's now begin the discussion of the API of Completable Futures. And as you'll see, this is a rather vast API, and it's somewhat intimidating to see it first. So we're going to talk about how to group all of its different methods into 5 categories, which will help you manage the large surface area of the abstraction. Why do we need to do this? The entire Completable Futures framework resides in one public class that has about 60 methods in it, which is pretty daunting. And these methods, at first glance, are really complicated, and they make you stand on your head, literally, to understand how they work. So it's been my experience that it's better to kind of think about these things in terms of different groupings. The reason why they do this, by the way, the whole design here was to use something called the Facade Pattern, which is a gang of 4 pattern that tries to simplify the interface to an even more complicated set of classes that are doing things under the hood. And so if you actually look at the Completable Future implementation, you'll see that in addition to all those 60 public methods, there's a whole pile of nested private classes and private methods that are doing all the gory stuff under the hood. And it's really, really, really gory. So if you think the API is complicated, imagine what the implementation looks like. We will talk a tiny bit about that. So it's therefore useful to have a bird's eye view of this highly method-intensive class. So there's lots of methods here, and we want to try to simplify as much as we can. So let's talk about the 5 different categories. Some of the methods that are provided in the Completable Future API are very basic. And if you already know Java Future, then you pretty much have this part of Completable Future. So if you take a look, here are the methods defined on the Future interface. And here are the corresponding methods that are combined on Completable Future, or defined on Completable Future. And that's because Completable Future implements Future. So of course, it's going to inherit those methods. And then it also adds a couple of other real simple things like join and complete, which are things that probably should have been on Future back in the day, but they added them to Completable Future. So these are the very simple methods. Not really that much better than the conventional Future interface. So I will talk about these things next time, but that's not where the fun resides. The other, 42 methods, or 52 methods, or whatever it is, the other 52 methods that are in this interface are much more advanced, and they fall into the following 4 categories. The first category we'll talk about, because they're the things that get the ball rolling, are the so-called factory methods. And you're hopefully all familiar with factory methods. We've talked about them a couple times in this class. Hopefully, if you took the 251 course, Intermediate Software Design, you've seen the factory method pattern. A factory method is just something that makes something. What's made here is an asynchronous computation that's either a one-way or two-way computation. So as we'll see, the one-way computations are not going to return results, whereas the two-way computations will. And one of the cool things about this is you don't have to do threading explicitly. You just call these factory methods either supply async or run async. And how this fits into the overall reactive programming manifesto principles is that these factory methods help to make programs more elastic by leveraging a pool of worker threads. And you either use the common fork join pool. All the methods here that don't take an executor will use the common fork join pool by default. The factory methods that take an executor, you can give the thread pool you want to be used. You can have a custom thread pool. You can use one of the predefined thread pools. You can control that. But the purpose of the factory methods is to support the elasticity principle. And you can see, if you take a look, well, I guess you can see it here. So there's 4 factory methods. So out of the 60, that's a relatively small number. Completion stage methods represent the bulk of the Completable Future framework. And that's where all the fun stuff lurks. Completion stage methods can be used to chain together these dependent actions that are triggered to do their processing when asynchronous operations complete. So we'll see that when the results of an asynchronous operation completes, then a completion stage method will get invoked automatically by the Completable Futures framework. And we'll also see that these methods support limited composition. These methods in Completable Future are all inherited from the completion stage interface. And I strongly recommend you go and take a look at the completion stage documentation, because it gives really good explanations of how all these things work. It won't make a lot of sense, perhaps, till we explain them all, but once you understand the overall model, it does a good job of documenting them. And there's a boatload of these things. There's like, some 40 of these methods. So that's the bulk of this stuff. Completion stage methods help make programs more responsive by not blocking the user code, or I should really say the user interface. Whoever the invoking thread is not blocked. Instead, the operations take place asynchronously in the background, and the code is responsive because you're not blocking the calling code. The fourth type of grouping of completable future methods, as you can see, they're very tiny, there's only 2 of them, are the so-called arbitrary-arity methods. What the heck is arity? So if you go look up arity in the context of programming, arity just simply means how many parameters do you pass to a method. So if you have a method with no parameters, it has 0 arity, an arity of 0. If you have a method that takes 1 parameter, that has an arity of 1. If you have a method that takes 2 parameters, that's an arity of 2, and so on. So as you might expect, an arbitrary arity method can take as many or as few parameters as you want it to take. Now, obviously, it helps to at least give it 1. But usually you're giving it a bunch of them, like an array of them. And these 2 methods, called AllOf and AnyOf, allow the Completable Futures framework to process a bunch of completable futures in bulk. And when you call these methods, they give you back a single completable future that's triggered either when all of the other completable futures are done, that's AllOf, or the first is done, that's AnyOf. So those are the 2 different variants of that. And this particular mechanism helps to make programs more responsive by not blocking user code. This is basically composition on steroids, because there are some composition operations available with the completion stage methods. You can wait for 2 things to finish, or you can wait for either of 2 things to finish. But arbitrary arity methods let you wait for n things to finish. That also makes your code more responsive. And then the 5th and final mechanism grouping for the Completable Future API are the so-called exception methods. And again, there's just a handful of them. There's more than arbitrary-arity methods, but there's not a whole lot more. And as the name suggests, these are designed to handle exceptional conditions at runtime where the exceptional conditions are occurring asynchronously. So something is running in the background, it fails, and then you need to inform someone, typically the caller or the handler, that something's gone awry. And we'll see that there's 3 primary methods that have a couple of variants there. And of course, these methods help to make programs more resilient. So thinking about that manifesto principle of resilience, because that way, if one asynchronous operation fails in a chain of fluent operations, the whole program doesn't come to a grinding halt. Just that one computation would come to a grinding halt. So it makes things more graceful. OK, so that's the end of the API overview. And again, I wouldn't expect anybody to just hear this and be off and programming completable futures. But obviously, starting next week, we will start going through each of these things in more detail. First, we're going to cover the basic methods, which are very simple. You're not actually going to use them because they're just not that much better or different than using Java futures. And then we'll go through each of those groupings. And I think you'll be really interested to see how those things work. They're super, super cool. And once you get your head around the patterns of programming asynchrony, they're really powerful. But it does take a little while because most people don't think that way out of the box.